Okay, so after the fertilization, let us see how this Polysiphonia, how it cares for its embryo. Okay, what are the changes that occur? Okay, now let's look at the post-fertilization changes. Okay, at the starting, just after fertilization happens, one auxiliary cell will come from the supporting cell. You remember, girls, we had a supporting cell, and from the supporting we got one basal cell and then two lateral cells. Okay, so from this same supporting cell we will get one auxiliary cell. I'll just show you, it'll be very easy. Excuse me. Okay, this is your, let me pull it down. Okay, this is your supporting cell. Okay, and then here, this just next to it, this one, that is your auxiliary cell with the haploid nucleus. Okay, see that? That is your auxiliary cell. Okay, and it is haploid. Okay, so this one you can see the basal sterile cells, the usual, right? Remember, remember in development of carpogonium, we had seen that. Okay, so let's continue. Okay, so at the same time, remember those lateral sterile cells? Those lateral sterile filaments, they will increase in length. Okay, so around 4 to 10 cells by cell division as well as elongation, and that basal sterile initial will divide to form two-celled filament. Okay, so this was our supporting cell. No, then we had one basal cell and two lateral cells. No, then what happens is that this basal cell will keep on dividing and elongating. Similarly with the lateral also, they will elongate and divide. This is lateral, they were elongating and dividing. So from the basal cell also, they keeps on dividing and elongating. Let's look at the image. Okay, you could see that basal sterile filament. Okay, these are elongating, right? I'm not able to find the lateral filament. Can you see it? I'm not able to see it. I cannot find it. I cannot see it. Anyway, so you are getting, okay, that they are also elongating. Both the basal and the lateral will keep on dividing and elongating. Okay, now that axillary cell, it has a single haploid nucleus. Okay, so I had shown you that. Then a tube connection will be developed between the auxiliary cell and the carpogonium. Okay, let's look at the tube connection. Okay, this is the carpogonium. Okay, then this is your auxiliary cell. Okay, they are just next to each other. Can you see them? These two. How do I maximize? 1 minute, girls. Let me just maximize. Okay, I think now it'll be, see, you can see this connection, no? There, that one. This is the carpogonium. This one is the auxiliary cell. So if they are going to form a tube connection, means something will pass by to something. Okay, let's see. That must be the guess in your mind. So let's see what will happen. Where we have reached. Okay, a tube connection. Then that carpogonial nucleus, okay, because it was already a zygote, no, it is diploid, no, because of the fusion, it will divide by mitosis into two nuclei. Okay, so this is the zygote, no, 2n, it will divide. Okay, it will divide. Then one of that one will be transported to the auxiliary cell and the other one will remain in the carpogonium. So our guess was right. So this tube, okay, so this one inside is the zygote. Okay, in the carpogonium, that's the zygote. Then this zygote will divide into two and one will go into the next cell, that is our auxiliary cell. So it passed by into the auxiliary cell. Okay, let's see again. Okay, let's see again. Okay, it has migrated to the auxiliary cell. Where migrate to the auxiliary cell. This outgrowth after separation by a partition wall forms gonemoblast initial. Okay. Let's see the gonemoblast initial. I am not seeing. Oh, there. We can see this one. Okay. So, this outgrowth, no, there is one outgrowth here. It will form an initial known as the gonemoblast initial. Okay. This outgrowth, okay, remember from the auxiliary cell came a tube, right? This tube. And it connects to the carpogonial zygote, right? The zygote. So this outgrowth, this one, it will keep on growing and form the gonemoblast initial. Okay. Then many more gonemoblast initial cells will develop on that auxiliary cell, and they will keep on dividing by mitosis to form the gonemoblast filament. Okay, so if this is the auxiliary cell, this one is a gonemoblast initial, this one. So many will keep forming, and they will keep on dividing by mitosis and increase in size to form the gonemoblast filament. So let us see the filament. I'm not seeing the filament. I only see the gonemoblast initial. Okay, it's all right since I have drawn it by my finger just now. Then the terminal cell, 1 minute, my brush, okay. Then the terminal cell of the gonemoblast filament will develop into the carposporangium. Okay. Sporangium is like a what to say? It's like a balloon, remember? Sporangium of Lycopodium, right? So then we will get this balloon-like structure called as this carposporangium, which will contain the spores, no? Carposporangium will develop from this gonemoblast filament. Okay, now let's look at carposporangium. Okay, now do you see these carposporangiums? Oh, I want to expand it. This is one carposporangium, this is one, and these all came from gonemoblast filaments, okay? And that gonemoblast filament came from gonemoblast initials, okay? So these became gonemoblast filaments, and slowly those gonemoblast filament will become into the carposporangium, okay? So what is inside the carposporangium? Obviously, it is the carpospore, no? Because we have done Lycopodium, it is very easy for you to understand. Okay, so 1 minute, where were we? Okay. So the carposporangium will form a single diploid carpospore. Okay, so now we have reached into a spore. This is the carposporangium, then this is the diploid spore. Okay, this one inside. Carpospore. We have already seen the diagram. So during this development, the auxiliary cell, supporting cell, carpogonium, and some cells of the basal and sterile filaments will fuse together and form an irregular cell known as the placental cell. So just like humans, they need a placenta, no, to get nutrition. So even these Polysiphonia, no, the carpospores, the zygote, they will need, right, they will need nutrition. So the nutrition comes from the auxiliary cell, the supporting cell, the carpogonium and other cells, okay, like the basal and sterile filaments. So none of those cells we studied about are not wasted. Remember, we have the auxiliary, we had one auxiliary cell and one basal cell, then one sterile cell, right? Then those lateral cells, right? They all fuse to form that placental cell. Okay, there, this bottom part is the placental cell, and it came from all these previous cells, like the basal sterile cell, the supporting cell, that auxiliary cell. It came, 1 minute, let me just expand it. Okay, this one, no, the basal cell, these the auxiliary cell, okay, these, they will fuse to form that placental, there, placental cell. Okay, this one, this D, this placental cell. Okay, now let's see what's next. Then the placental cell is haploid. Okay, so remember, because only the zygote is diploid, no, only that ovum was fused, right? So only that is diploid. The rest came from the haploid cell, right? So the rest of the haploid nuclei of the placental cell will simply degenerate and provide a nutrition function. Okay, so they will melt away and form as the example, how can I say, like Cerelac, no, like that liquid Cerelac, just like that. So they will degenerate, they will die off, and they will form the nutrition. Okay, so the placental cell, the filaments and carpogonia, they are covered by many vegetative filaments, and they will form an urn shape known as the cystocarp. Okay, so they are covered by so many filaments, right? Remember, sterile filament, lateral filament, all those, they will form that urn shape. The outer covering of cystocarp is called as pericarp. Okay, I have already told this. Then the diploid part of the cystocarp represents the carposporophyte. The diploid part means only that zygote part. Okay, the rest, these are all the placental cell. No, this supporting cell, axillary cell, basal cell, lateral cell. These were all diploid, all N. But only this 2N part, the zygote part, that is your sporophyte. Okay, so let me remind you again, gametophytes. So remember, we did in Lycopodium the 3 types of gametophytes. No, we did cernum, then phlegmaria, then we did clavatum. No, these were all haploid. No, all N. But the sporophyte of the plant body was diploid. Okay, so even here, the whole thing was haploid. No, it was a gametophyte. But now, from this 2 and the zygote, we will develop a sporophyte. So sporophyte is twice N and gametophyte is N. Okay, I should not be repeating, but I just have a feeling, because you are still in first semester, you have to base your you should have a good base, no? Okay, so some cells of the basal and sterile filaments, they will gradually degenerate. Okay, and then they will degenerate and they will release those diploid carpospores. Okay, those diploid carpospores, because remember, the zygote, it will divide and redivide, right? It will release those carpospores, and from this carpospore, when it germinates, it will develop into a diploid plant. Okay, so suppose this carpospore came out. This carpospore came out, no? It reached on that ocean surface, then it germinate, no? It got the rhizoids and it will develop into a diploid plant, which is a carpospore. All right. So there, from the rhizoidal cells, the rhizoids will come out, and from the rest of the apical cell, the rest of the plant body will come out. And then the cycle will continue. So the opening through which that carpospore comes out is known as the ostiole. Okay.